This is the Progress Check 2 summary video for Prep for College Algebra. The learning targets for this upcoming progress check will be to identify the key characteristics of quadratic graphs using standard, factored, and vertex form, sketch accurate labeled graphs of quadratic equations using those key characteristics, and to write a quadratic rule to match a given graph. As we work towards the unit test, I've mentioned already that eventually you guys will need to be able to know these patterns by memory and not be able to use your notes, so I wanted to take some time to generalize some of these patterns. The x-intercepts for all the rules are always found by setting the equation equal to 0 and then solving for x. The y-intercept is always found by plugging in 0 for x, then solving for y. Line of symmetry can be found by calculating the number that's halfway between the x-intercepts. And then the vertex consists of the line of symmetry for the x value, and then whatever you get when you plug the line of symmetry in for x, and then solve for y. That becomes the y value. So no matter what form you're working with, these patterns can help you find these 4 pieces of information. Example 1, we'll look at sketching a graph of standard form. So our equation is y equals 3x squared minus 20x minus 32. We'll find the y-intercept first, since standard form is the most convenient form for identifying the y-intercept. If we plug in 0 for x, then that gives us negative 32 for y. Next we'll find the x-intercepts, and when we do that with standard form we use quadratic formula. Solving quadratic formula gives us the 2 values of 8 and negative 1.33. So those are our 2 x-intercepts. Next we'll identify the line of symmetry, which is just the first part of the quadratic formula, opposite of b over 2a. Since we've already used the quadratic formula, we can go ahead and use that formula. We could have also taken the values that we got for the x-intercepts, added them together, and then divided by 2. In order to find that same number. Finally, we'll identify the vertex. The x value of the vertex matches the line of symmetry. The y value is whatever we get when we plug the line of symmetry in for x. In this case, it gives us negative 65.33. Now the only thing left is to sketch our graph and to label our key characteristics. There's our y-intercept, our x-intercepts, line of symmetry with a dotted line labeled with the equation, and our vertex. This equation has a positive number that's out in front, so this one's going to open up. And that's what our final graph is going to look like. Again, make sure that all the points are labeled as ordered pairs, and the line of symmetry is labeled as an equation. Next example is factored form. We'll start with finding the x-intercepts, since factored form is most convenient for identifying those. We need to take each factor, set it equal to 0, and then solve for x. So that gives us the values of negative 1/4 and positive 6. Next we'll find the y-intercept, which is found by plugging in 0 for x. Simplifying that, we end up with positive 4. Next we'll find the line of symmetry, which we can identify by adding the x-intercepts together and then dividing by 2. So we'll add negative 1/4 and positive 6, cut that in half, and that gives us 2.9. Finally, for our vertex, the x value of the vertex matches the line of symmetry. The y value of the vertex is whatever we get when we plug in the line of symmetry for x. So plugging that into the equation and then simplifying gives us 26.04. Now we've got all of our information, so we're ready to sketch a graph. Label the x-intercepts as ordered pairs, y-intercept as ordered pair, line of symmetry as an equation, vertex as an ordered pair, and in this case this rule has a negative in front, so this is going to end up opening down. For our third example, we'll look at vertex form. We'll start with the line of symmetry, since vertex form is most convenient for identifying that. The line of symmetry is the opposite of the number inside the parentheses, so it'll be -7. Vertex form is also convenient for finding the vertex. The x value of the vertex matches the line of symmetry, and then the y value is the constant number on the outside of the parentheses, -12. Next, we'll find the y-intercept by plugging in 0 for x. When we simplify that, we get 86 as a result. And then finally, we'll find the x-intercepts by setting the rule equal to 0 in solving. First, we'll add 12 to both sides, then divide both sides by 2. To get rid of those parentheses, we want to square root both sides to cancel out the exponent. We need to remember to put plus or minus in front of the square root of 6. And since we're graphing, it makes sense to go ahead and take the square root of 6 and then round whatever our answer is. So I rounded to 1 decimal place, 2.4. Finally, our last step is to subtract 7 from both sides. And now we're ready to split off into our two separate x-intercepts. So we'll need to take positive 2.4 minus 7, which is negative 4.6, and then negative 2.4 minus 7, which is negative 9.4. We'll go ahead and write our x-intercepts as ordered pairs, and then that was the last piece of information that we needed, so now we're ready to sketch our graph. Identify the line of symmetry with the equation in a dotted line, show all the other points as ordered pairs, and this graph will open up since the value in front is positive. Now we'll take a look at some examples of writing a rule. In this case, we're given the x-intercepts, so we want to write a rule by using factored form. The x-intercepts on this graph are -4 and +9. So if we set up the rule with the matching factors, our factors would be x plus 4 and x minus 9. We want the factors to be set up so that when we plug our x-intercepts in, they give us 0 as a result. Then we want to choose another point from the graph. In this case, 1 is already labeled for us, 6 for x and -15 for y. So everywhere we see an x, we'll replace that with 6. Everywhere we see a y, we'll replace that with -15. Once we do that, we have an equation where a is the only variable left, and we can use that equation to solve for a. Last step would be to divide both sides by -30. And so our value for a is positive 0.5. Now that we have our a value, we can go ahead and put that back into the rule where we originally had the a, and then write the factors that we wrote to finalize our answer. Don't forget to check your answer by putting that into the y equals on the graphing calculator and checking to make sure that both x-intercepts and the other point that you chose show up on the table. Finally, we'll look at an example where instead of the x-intercepts, now we're given the vertex and another point to work with. So since we're given the vertex, we'll go ahead and set up the vertex form that would go along with that. Number inside the parentheses needs to be opposite the x value, so we would use x plus 4. And then the number outside of the parentheses would have to be +6 to match the y value. The other point that we're going to use in this case is -2 for x and 4 for y. So everywhere we see an x, we'll put -2. Everywhere we see a y, we'll put 4. That sets up an equation that we can use to solve for the a value. And that gives us a result of -1/2 for our a value. Notice that this graph opens down, so in this case it makes sense that the a value ends up being negative. So the final answer for our rule would be -1/2 times x plus 4 squared plus 6. Again, make sure you plug that rule into your calculator and verify that those 2 points show up on the table to make sure that your rule is correct. If you're wanting any additional examples for writing rules that match graphs, then check out the tutorial video that's on the blog.